Hey, all this video is about linear inequalities. I'm going to go through a little bit of notation first. So that's less than, and this is right out of the lecture notes, so if you open up the notes you can see all this. Less than, so when we graph them when they don't have the equals, we're going to use these open dots on our endpoints. So less than goes this way, we're less than whatever the value is. Greater than, so it goes this way. And greater than, the graph goes that way, kind of the same as the arrow, if you notice. And then same idea, but less than equals to, greater than equals to. Only difference is we have a solid dot, but less than is still going this way, same way as the little arrow. Greater than is still going this way, same way as its arrow. The inequalities are going to solve exactly like the linear equations, with one exception, and that's right here. When you multiply or divide an inequality by a negative number, you need to reverse the direction of the inequality. And let me show you really quick why that is. If we think of a number line, we got, 0, 1, 2, 3, and -1, -2, -3. So if I write 2 is less than 3, so 2 is less than 3 because it's to the left on the number line of 3. That's totally true. But then if I multiply both sides by -1, then I get -2 is less than -3, and that is not true because -2 is to the right of 3 on the number line. And so when we multiply by a negative, we have to switch the direction to keep this true. So while +2 is less than +3, -2 is greater than -3, so we have to switch the direction. Okay, so on to kind of the regular problems. So for number 1, very friendly little, what would have been a linear equation. Now it's a linear inequality because of the less than. And so we're just going to subtract the 6 over like we would. And we'll get x less than or equal to -2. So it used to be we just got x equals -2, and if I was going to color the answer over here, I'd throw a dot down on -2. But now we have the x's are going to be everything less than or equal to -2. So that means it's everything here on the graph. So we want to do an arrow like that. And so that's our solution set graphed. So this one, it's multiplying, so we're going to divide. But the thing we got to remember is I just divided by a negative, so like I said on that first page, that means we have to reverse the direction of that inequality. So, and it's always going to be on the last step of the problem, because that's when you do the divide, so that's when you just kind of have to pay attention for reversing that. So x is going to be greater than -3. So we're going to go to -3, but we're going to use an open dot this time because we don't want to include -3. So this says everything up to -3, but not the -3 itself. And here the x is going to be greater than that. So that's going off this way. The next one, we got a -1/2. And so I will undo that with a -2 over 1, if you like. This side I'll just write -2. So then this all cancels, and I have x is up. I did multiply by a negative, so I got to reverse it, less than 6. So we come here to 6, put an open dot, less than, so again you can kind of think of that as the arrow, and so it's going to go out that way to infinity. So this one I have to do a little bit of distribute to get that going, so we'll go 2 times 3 is 6, 2 times 5 is going to be -10x, and then greater than or equal to -14, and I'll subtract my 6 over. So -10x greater than or equal to -20, and I'm dividing by a -10, so I flip my inequality, and x is less than or equal to 2. So that's going to be a solid dot on the 2 for the equals, and then less than is going to go right out that way. So the next few problems are all ones that if we're in a lecture section I would have you try. So let's see, let me bring this one down just to make it a little bit clearer. So I have a fraction, so I'm going to use the reciprocal. So I'm going to say -3 over 4, -3 over 4. If it helps, throw that 1 under there. And cancel that. We're left with just our x. again, I multiplied by a negative, so I got to remember to reverse that. And this would equal negative 24 over 4, or negative 6. You also go 4 and 8 twice, times 3 makes negative 6. So x's are less than negative 6, so we'll go to our negative 6, and the less than goes that way. Okay, so for number 6, we'll subtract our 6 first, and that's going to leave us 7x greater than 21, and we'll divide over the 7, and x is greater than 3. So we come to 3, open dot, x's are greater than, so again, think of the arrow, that's going this way. This one we got to do a little bit of work to get this isolated, so we're going to run the negative 6 through, and that'll give us 8 minus 6x, minus to minus will make a plus 18, less than negative 4x plus 12. Now I'll go ahead and combine some terms here first. So that's going to give me positive 26 less than negative 4x plus 12. I'm going to bring my 4x over. That'll be negative 2x plus 26 less than 12. And then subtract the 26. Negative 2x is less than negative 14. And then right here, I'm going to divide by a negative. So x is greater than 7. So it's up here and out that way. Okay, these next two are ones that I would do. So this one, I wouldn't clear the fraction because I don't need to yet. So I could subtract the 2 first, which makes me want to subtract the 2 first. So then I have negative 3 halves x is less than or equal to negative 3. And now I can just use the reciprocal. So I'll just do this with a negative 2/3. And all that stuff is gone. And I did it again, multiplying by a negative. So 3's cancel, minus and minus makes plus. So x is greater than or equal to 2. We'll throw a solid dot on 2. And go that way. And now that next one, I would definitely I would clear the fractions. So I'll do this. And we're going to go 15 and 15. And that's because, remember, 3 and 5 both go into 15, so I'm going to use the LCD. And let me show that cancel step just because. So the 15, you can also think of it as 15 over 1. So I'm just multiplying each of the numerators by 15. And if you've gotten to where you can get to this next step without this, definitely do that. This is just to try to show people where the canceling is happening. So here I can go 5 into 15 and I get negative 3x. And if you look 5 and 15 right there, I could just go 5 goes in 3 times and be done. Here I could go 3 goes into 15 5 times, which is exactly what that's showing. And here 3 goes into 15 5 times. 5 times 2 would be 10. Or here 30 over 3, still 10. So when you get to where you can do that, definitely just do that. But that can help in between. Here I'm going to add this 15 over. Sorry, the 5 over, and I'm going to get a 15. And I'll divide both sides by negative 3. And x is greater than negative 5. It'll be right here. And greater than, so we're going out to infinity. And then these last two are the ones that have you guys try in class. So here I'm going to move this 8 over first. And that's going to get us negative 3/4 x is less than or equal to negative 3. And then we'll do the reciprocal trick. So it'll be negative 4/3. So on this side, all that mess cancels, and I'm left with x, and then careful to flip the sign, greater than or equal to, 3's cancel, negative and negative make a positive 4. So a solid dot on the 4, and then we're going to infinity. So x is greater than 4. And then here again, I would definitely clear the fractions. So we'll just do a 6. We'll do this set by 6 over 1. So I can think 12 over 3x minus 30 over 6x, or sorry, 30 over 6 less than 6 over 2. So if I reduce, I get 4x minus 5 less than 3. If I look at it just up here, 2/3 of 6 is 4. 6's cancel, I get the minus 5. 2 goes into 6 3 times. So that's another way of looking at it. Once I get here, I just add the 5. And that gets me 4x is less than 8. And then divide over this 4. And x is less than 2. So there's our 2, and then less than, so we're going that way.